Hello there, and welcome back to another episode of All Around Azure. Super excited to be here, as always, with you. My name is Jason Hand, and one of the hosts for this show. And we've got another really great episode lined up, bringing in some new tech that we haven't talked about yet on All Around Azure. I've got one of my good colleagues, good friends, as part of the advocacy team, who's going to be sharing some things with us about some technology that I've never had a chance to play with. So I'm super excited to learn some new things, but more excited to just sort of catch up with our guest here. So without further ado, everybody, please say hello to our good friend Adi Polak. How are you, Adi? Can you hear
I'm
me?
good. I'm good. Yeah, I can hear you loud and
Great.
clear. Super excited to be here today with you and your awesome show. Um, yeah.
Awesome.
What about you? What's going on?
Well, as we were chatting just before the show, spending a lot of time focusing on this content here, this new episode, or not new episode, but new series of episodes that we've been trying to put together, with the intent of being up on Microsoft Twitch, which is where we're primarily streaming, but also being simulcast over to Learn TV and trying to work out all the details of getting that going. So some of us that may be catching the show today might be catching us on Twitch. Some of us might be on Learn. We're going to look into some other destinations down the road too. But to answer your question, most of my time lately has been right here in front of the camera doing either these streams or some other content that's really focused on helping people upskill in preparation for the AZ900 certification exam. Have you done any certification exams yet, Adi?
No, not the one we have yet, but
No.
it's coming.
Yeah, I think it's good. The AZ900 is a good, just, it's the Azure fundamentals. So I would say of all of the certifications out there, one, it might be the easiest one, although I don't think it was easy. Two, you kind of need to know that stuff before you really focus on some of the other certifications because it should be like a prerequisite, I guess, if it isn't. Um, but yeah, so I think spending some time focusing on that kind of stuff and getting the certifications is important to a lot of people, and us trying to help them realize, like there's really great Learn modules in the new, free online Learn stuff that we've got. And then, you can get yourself a free Azure account so you can go in and really get hands-on use for a lot of stuff too as you start to prepare for a certification. So anyway, just doing our usual thing of trying to help people out, solve the problems that they have, and a lot of them lately is changing their skill sets around a little bit. Maybe they want to do a career change. Maybe they've just got a little bit more time on their hands with everything that's going on, and they're wanting to learn some new tech. Yeah, so I don't know. I'm all over the place, doing lots of different things as usual. How about you? What have you been up to?
Well, first of all, that's great that you're definitely, first doing and taking those exams yourself and then sharing it with others. I think that's fantastic. Regarding what I'm doing, well, I've been working a lot with Spark, as you probably know.
Mm-hmm.
I'm looking into processing videos at scale, trying to work with a library named OpenCV. For analyzing videos and kind of get insights on what's going on, if there's a movement, if there's a car, if there's a person in the picture, stuff like that. Pretty interesting. It's a combination of multiple frameworks. So OpenCV is in C++, and there are a lot of wrappers for OpenCV. It can be Python, it can be Java, it can be .NET. And then, there is Apache Spark, which is mostly Java JVM based, so Scala, Java, but there are a lot of different programming languages that we can work with, like .NET, R, Python. So a lot of exciting things. And recently, I started to work with Synapse, which is still in public preview. But it is super exciting. So I'm kind of trying to connect Synapse to Azure Databricks, to Azure Machine Learning Studio, and kind of get a feel of the different workloads in each one of them and how they connect and work together.
Mm-hmm.
So that was that's pretty interesting.
And that's how
I
we got.
think in the
Yeah,
yeah.
that's how we got to today, right? Like this, the stuff that you've been really poking around in. So you threw out a lot of terms there, a lot of names of some stuff that might not be totally familiar with everybody. So can you back us up and tell us what is, first of all, what's Apache Spark? Because we're going to be talking about that. And then what is Azure Synapse, and what is Databricks? Give us just a quick example of or definition of those.
Sure. So Apache Spark is a software, a framework that help us compute, run different compute workloads on top of big data. It's an open source, pretty interesting one that also we can do what we call batch processing. It's basically batch processing is when I have data that I collected for some time and I want to run on it. Let's say I have data that I collected for a whole week, and now I'm writing some code and then I'm analyzing this data. So that will be batch processing, and I can have something like a scheduler that does it every week for me, that runs the same code every week for me. One of the common scenarios for that are reports that we usually see people extracting reports, or maybe pouring that data into some Power BI or something like that that can show me that I can go through and see and play and poke with the data. So this is regarding Apache Spark. Regarding Synapse, it's still new. It's kind of, I don't know if you know SQL Warehouse. It's not that, but it's also, it combines that as well. It's basically a workspace that helps you do everything related to working with data and analytics. Pretty interesting because it combines a lot of different functionalities as well, and it works well with our different Azure solutions for Azure data solutions.
And correct me if I'm wrong too, but I believe it works as far as compatibility goes with other external data sources, even other cloud providing data sources. Am I wrong on that? Can we go in?
I didn't get to.
Yeah.
So I didn't get to that part yet, but I'm still investigating. I know within Azure it works with a lot of different data sources and a lot of different services, but I'll let you know once I figure it out.
Great.
Right, and we have another one, right? We talked about Azure Databricks.
Right.
So Azure Databricks is another service that we offer on Azure, and it's a managed Apache Spark environment. So it's optimized, and it's actually known to be 50 times faster than running open source Apache Spark.
Wow.
So yeah, so that's really interesting because the Databricks company, they invested a lot in optimizing Spark, and also some of their founders are actually the people that started the Apache Spark open source. So that's really interesting. And actually, one of the challenges there that I didn't mention, that Apache Spark is a distributed system. And you probably know when we talk about distributed systems, we talk a lot about networking and throughput and all this kind of stuff. So it's not only processing the data itself, it's actually having the whole communication between the different machines and optimizing it and shipping the data in an optimized manner as well. So there's a whole topic on it can be a whole different session on how we can even think about starting optimize Apache Spark workload. So that's pretty awesome, I think.
Okay. Yeah, thank you for that. I know, I mean, I'm somewhat familiar with some of these things, but there's just, wasn't it, I want to say like even just last year at Ignite when we first started hearing about Synapse? It's because it's super new, right? Like or maybe it was a new, some sort of new functionality with it. But I remember that being my first sort of alert to, oh, wow, this thing is, I hadn't really paid much attention to this. I'd heard the name around, but I've never used it myself. And I saw a demo And I was like, this is amazing. Just like I feel like I say with lots of things that I haven't had any exposure to. And you know what? I have to blame you. I think it's every time I work with you, you show me something I didn't even know you could do, blow my mind. And yeah, so anyway, really excited for you to do more of that today, but with not just me, but with everybody on the stream here. So welcome those that are kind of rolling in right now. If you're just joining us, this is Adi Polak, who's a good friend of mine and colleague at Microsoft Cloud Advocate team, residing out in Tel Aviv, I believe, right? Still is where you are.
Yeah, in Tel Aviv.
That's
true.
So thank you so much for bearing the time zones with us and actually being able to join us. So I really thank you for that. So anyway, just so we don't run out of time, do you want to switch over and we can start kind of talking about some of the things you wanted to show off today?
Yeah, sure. So, well, first of all, thank you for having me. I'm excited for that, and I hope all of you will learn new stuff. One point is please ask questions. I will try to follow up with your questions on the chat. So I'm looking at the chat as well. Please ask questions. It will help me focus a little bit because sometimes I have like a tendency to maybe skip a term of two. So keep me honest.
Yeah, sounds good. Okay, cool. Well, I'll switch over to your desktop here and we'll take it from there. And yeah, please let us know if you have any questions or even comments on using any of these things that we're talking about.
Cool. All right.
You have the wheel.
So awesome. Thank you. All right. So that's Azure Portal. You probably know it already. And here I'm already looking at my Synapse resource. But if I want to create a new one, I'll just go to this second one. As you can see, the workspace preview. That's the one we are seeing today. And like it mentioned, still public preview. So we might see some weird glitches or anything like that, but that's fine because it's still in preview. So once you create your Synapse environment, basically, you can see all the way here that you get
in the
three
default
different
web port,
links.
which is easy.
You get the SQL endpoint, and this is if you have a SQL pool. You have the SQL on demand, which is really cool because that means you only pay for the data that you're consuming. And you have the development endpoint. And when we scroll a little bit down here, you can already see that I created something called Apache Spark pools. And this Apache Spark pools are based on open source Apache Spark. So not optimized, not tweaked, just the open source Apache Spark, which is different than the Databricks, like we said before.
Gotcha. Adi, you might need to scroll just a little bit up. We're at the very bottom of what we can see with those Apache Spark pools. If you can, I don't know that you can actually scroll anymore, but
can you see this
yeah,
one?
there we go.
Can you see it now? Oh,
yeah,
okay.
Now we can see it. That looks great.
Awesome. So I can click it. Let's go with the SQL that we have. And I can actually see the geo backup if I need it to be. I can encrypt the data. I didn't do it for this demo, but I can. And then I can see the different usages and Q queries that I can work with. And let's go back. And let's look at the Spark pools that I have. All right, basically pretty simple. Doesn't give me anything much from here, but I can change the access control if I want to. I can add, when we work with Spark, since it's a distributed systems, it can ask us for something called environment config files. And environment config files are crucial if you want to bring different libraries that are not packed already with Apache Spark. So if you want to do that, we can provide it. We can give it here, basically, by providing the config file that we want to work with. So just keep in mind that if you want to work with different libraries, you should provide it right here.
Okay.
All right. going into our Synapse, going back, clicking that, and now we actually want to work with the workspace itself.
I see. So that takes you to a separate interface outside of the Azure portal.
Exactly. Like a lot of product that we have, it has a a separate workspace for us to work with. Sometimes, oh, maybe because I have it open here. Okay, so let me just close it. But the way it works when I'm just going in, this is what I'm going to see on my screen. So I have the different functionality. I have ingest, if I want to ingest data into my cluster. Jason, maybe you're familiar with the different Azure copy capabilities that we have.
With regard to Synapse or just in general?
General Azure copy, CLI.
Yeah, I mean, probably CLI. And most of this time when I'm playing around with large data, I mean, I don't play around with anything nearly the size that you are. But I use the Data Explorer tool to do a lot of the kind of movement of files around. But I've also, as I've been learning more about the logic apps, I've realized like copying and moving files back and forth between not only regular SQL databases and just normal data sources, but you can put them into tables. Like you can copy and move things all over the place. So I'm assuming and it's super simple. So I'm assuming that's kind of like what you're getting at.
Exactly. So I can do, basically I can copy and move my data from one place to the other. I can define the different connections. So here I already start playing with it. I can look at different data store that we have in here. So we can connect different data. Let's say if I have database, I don't have database. But if I'm working directly with Azure, I can create a new connection if I want to. And it gives me already multiple capabilities that are already built in. So I don't need to write any code. I just need to pick the one that I want to work with and, start rolling with it. And here we have the generic protocol that I didn't work with yet, but maybe that's the one that I should use if I want to work with different clouds. So if I want like a hybrid environment and work with data from different clouds, maybe that's the place. But once I'll figure it out, I'll let you know.
Yeah. Okay. We'll do that the next time. We'll have a follow-up episode.
Yeah. Yeah. So this is the place where I can pick and choose and basically move data from one place to the other. I already connected a few of the databases that I have. So I have Azure Data Lake Gen 2 named architecture, and the other one is Data Lake, just Data Lake architecture. So I can move and switch between that. So once I define my source, so let's just do that.
While you're doing that, I want to say hello to everybody who just joined us from the Visual Studio channel. We were just rated by our friends over there at Visual Studio. So thank you all for joining us. We've got our good friend here, Adi, who's teaching us about a number of things. Right now we're in Azure Synapse. So welcome to the show and glad to have you here. Let us know if you have any questions.
Cool. All right. This one will take a little bit. So now I'm enabling the interactive authority capability, which basically allows me to do the copy from one place to the other. It always takes a little bit. But I can say, listen, I want to take it from my Azure subscription, and I can pick up the subscription that I work with. And then it gives me the different blobs, Azure blob storage that I have. So let's say I want to do, this storage. Did you see the green thing that popped here? It basically checked my keys.
I did. Yeah, I did.
So I checked my keys and make sure I can do that. It's still in the phase of enabling interactive authoring. Once this will be done, I will be able to test my connection down here And once that's good, I know I can fully connect and do the copy data. So this usually take a little bit.
So this is really just linking the service. It doesn't begin the process of ingesting anything just yet.
Right. So this just, well, once I'm done with that, it just define the pipeline, the data pipeline, or of where I want to move my data. So I have the source and I have the destination, and I'm just defining that. And then I can do either schedule that specific pipeline, so it will run once every hour, once every day, once every week, or I can do it just one time if I want to.
Okay, that makes sense. What's a use case for running it on a scheduler? Like, is there any examples you can give us where people just have that much data that they, or maybe it's not even a volume or quantity of data, but they're bringing it in every single hour? How does that work?
Yeah. So let's think about a system where I have batch processing, like I said in the beginning, and also stream processing. So stream processing, sometimes it's even related to event-driven architecture. So for every event that a system gets, I want to act immediately, right? So it can be, let's say, some financial transaction, right? Let's say now you're going to the store, you want to buy something. You either use your credit card or your smart device or anything like that, and you want to get the approval right away. So that's a more event-driven system. And that's great because you want the response immediately, right? You don't want to wait in the store for a whole week to get your transaction approved.
Exactly.
But what about if we want to take that data and analyze it? And by analyzing, I mean combining it with different data and look at different domain or aspects of that data. So for that, I want to save it somewhere. Usually I will call it like a data lake. I will save it somewhere there, and then I would run either my Spark workloads for batch processing, or maybe even just simple code. If that's small data and it fits, I can even run a simple code. Oh, that's done. All right. I can even run a simple code and just get the information that I want, or I can put it directly into Power BI and get the information and analyze the data and get everything I want out of that. So this is just one simple example where I need sometimes I need also the ability to do stream processing, and then the ability to do batch or historical processing over the data that I have. Usually for most of the scenarios or for stream processing, we don't always need a big data approach. But once we start collecting those events, it adds up, right? It's like, so once starting collecting that, it adds up. And once it's added up, sometimes we need things like Spark to analyze the data. All right, so I have the connection. I'm gonna press next. It should give me right, the file or folder. Yeah, let's go with that one. See what we have in here. So today, actually, I want to show you the Austin Animal Shelter. But we're just going to move yeah, it's really cool data set. Apparently, Austin, I didn't know that till today. Apparently, Austin have a lot to do with open sourcing their data, and they're trying to build a more smart city. So they encourage people to go and get the data and analyze it and work on it.
Very cool.
That's, yeah. And as you can see here, I already split to different directories. So usually when I work with the concept of data lake, I have at the base, I have something called raw. So that's my raw data, the way that I get it. Usually when I put my transaction, pour it into my database, I usually put it under the raw directory. Okay. And then I'm slowly building it up. By building it up, I'm refining it or curating it or
Mm-hmm.
maybe combining it, merging it with other data.
Oops. Yeah, no, that totally makes sense. Like with every step, you kind of just make minor changes. And is it things like finding errant characters within a field, or is it renaming fields? Like what types of things are you doing to massage this data into different states?
Yeah, so it can be renaming it, formatting it, sometimes give it a special type. Let's say it comes at the shape of a string and I want to change it into an int. So this is one of the things that I want to do. Maybe preparing the data for, data scientist workloads, machine learning.
Mm-hmm.
So maybe I want to combine different tables together. So I want to combine data that comes from the Austin Animal Shelter, and then I want to combine it with some e-commerce in Austin. Maybe I can find some information about that. Maybe people that buy, let's say, dog food pretty often might adopt a kitty. Who knows?
So this, I forgot what my question was, but something about the way that this data. First of all, where do you find this kind of data? Is this, you said it's open source? Is there a location online where we can find this type of stuff to play around with?
So right in here, Kaggle is one of the known. Can you see it? Is that a good size?
Yeah, no, that's great. Yep.
Okay, cool. So Kaggle is one of the great websites for different data engineering, data scientist challenges, and they usually publish open source usually open source data together with a challenge. So this data specifically was published by Austin Animal Center Shelter. And they actually have had, it was 2 years ago, but they had a specific ask of people to kind of try and analyze and define the patterns of, which animal are more likely to be adopted, and what's going to be the outcome of different cats and dogs. So you can find it scrolling here. You can find also, a little bit of the context of the data itself, where you can find it, and also an API. So if you want to read the data in live, you can do it as well.
Cool.
Yeah, a little bit about the data, acknowledgements, inspiration, and here all the way down, you can download it. So that's pretty cool. Sometimes they have, let me just put that on the chat, the link. Sometimes some of the challenges will have prizes. It can be like 30K US dollars. Some of the challenges, if people figure that out. All right. Going back, so we say we're going to copy our data. So we got the connection done and we defined the data set. So I'm basically copying one of the files. I don't want to do binary copy because this data is pretty small. I don't need that recursively. Okay, max concard connection. Let's say 2. I just don't need anyway, just one file. And here it's really interesting, filter by last modified. So I can actually filter the data on the data that I'm copying, building the pipeline, and I can decide, hey, I want data between that specific range. So that's the start time, that's the end time. Just bring me the files from the different from the directory that in the specific time range. So that's really neat because I don't need to do it myself, and it's already in the file system. There is a notion of time.
Mm-hmm. Yeah,
all right.
Okay. I remember my question from earlier was this whole process of changing fields from a string to an integer, or number, or vice versa, and cleaning up the data. That is that known as data engineering, or there's a specific term for that process, right? It's not data engineering, is it?
It's kind of a data engineering. It depends on, I guess different companies call it differently.
Mm-hmm.
But yes, processing the data, cleaning it, making it fit into the schema. The way I see it, yes, absolutely a data engineering task. But it's not. I mean, it's one of the many tasks that a data engineer
Mm-hmm.
do and have.
Right. We've
Um,
got a question in chat too about the using the timestamps for ingestion. Can you see the chat there?
yeah. So what's the difference between that and partitioning by timestamps? Basically, you can partition by timestamp, but here I'm still defining the copy data, the pipeline itself. I'm not running it yet. So once I'll start running it, it will be applicable. But if you work with a lot of data, most of the time, we have a tendency to partition it by timestamp, because this is when we don't define one copy pipeline. We usually want to work on it. So later on we'll see. So let's say I want to load a Spark. I want to start working with Spark and create some data pipeline with Spark. Sometimes I will have very defined logic into what is the timestamp that I want to work on. So let's say I want to work on now and minus hour. So this is like the time range that I want to take from. And having that in my, so partition by, usually I'm showing it in the file path. It's going to show me like one of the directories is going to be the timestamp, or I'm going to have the timestamp somehow in my file. So I can filter it out before reading the data into memory, but we're going to touch that really soon. Okay. When we'll look a little bit more into Spark. All right, so let me just go through that. It's already shown me the schema, a little bit of the data I have in here, different animal ID, age upon outcome and such. And then I want to give it some destination. So I'm just going to, let's say the default storage, let it load, right, folder, raw, oh, not the raw one. Let's go back. This is my system folder, root, and I'll just gonna dump that here as well. I'm basically going to copy it.
Okay. Just right back into the raw folder.
Yeah. All right. Just use the same file name, copy behavior. I can decide if I want to either merge the files that I'm working with or preserve the hierarchy, if I want to copy a whole directory that has a hierarchy inside of it, if I want to flatten it. So I have the all the options here. Max connection, just go with 1 because we don't need more than that. Block size 4 should be fine. All right. Text format, column delimiter, because I'm working with a CSV here. I don't need to add header to the file because it's there. Double quote, null value, nothing of such sort. But sometimes when I work with other file types, I do need to to give it more attention. Fault tolerance, skip incompatible rows. Storage connection name. We are working with the workspace folder. You know, I don't need that part. The logging settings, that's good. Data units, degree of copy. Okay, don't need all of that.
So a lot of this stuff you just leave at the default settings. It looks like.
Absolutely. Many times I would, unless, I need fine tuning. I'm working with very specific data or very specific file format that I want to make sure to keep. And that gives me the ability. So for example, if I have error key in my directory, maybe it's a good opportunity to flatten it if I need to.
Yeah.
So I can leverage that. I don't need to write code to make it happen, basically.
Yeah.
All right. And now it's deploying it.
And so now created the pipeline, and now it's in the running pipeline. Was that running pipeline step the actual ingesting the data and placing it into that raw folder? Yeah.
Yeah, that was the running pipeline
Okay.
part.
That was pretty fast. Although,
Yeah,
how many records was it? Did we even look at how large that file was?
It's pretty small.
Yeah.
Again, for the demo's sake, didn't
Right.
pour a lot of data into it, so pretty small.
Mm-hmm.
But now that I have it, I can actually see it. That's the JYI, so I can rerun it if I want to and maybe change it or tweak it, or schedule it if I want to do something more fancy with it. So it's like just one of the things I can do. All right, let's look at our data sets. So here I can see that I have two different tabs that I can look at. I can look at the workspace databases, and here I have the SQL pool, the SQL pool data. I have the base, which is basically Hive for Spark. So Hive helps me with the meta, basically like the meta store for the data that I work with. I can easily use it to find information on the tables that I'm holding and also hold the tables. It worked pretty well with Spark. And there is a default table that comes out of the box. So the base table I created before that.
Gotcha.
And I'll show you how you can do it. It's really super easy. Okay, so that's the workspace. This is what I have. And I also have linked storage. So do you remember in the beginning I showed you like I can connect different storages into to work with the Synapse workspace?
Yeah,
so
like
that will
point and
appear
click
here.
And connect about, I don't know, seemed like 100 different types of storage options.
Yeah, true. So I connected two different storage accounts and some data sets from the copying that I did before, because I copied the data directly into a data set, so I can query it later from a data set if I want to. But this is, again, for the sake of the example. All right, so this is the folder that I have, and I want to start working with it, right? I want to start looking at the data, understanding what's there is in there. I can do SQL. And when I'm working with the SQL, I can connect to SQL on demand. Like I mentioned in the beginning, I only pay a specific amount for the data, or I can connect it to a SQL pool that I created before that. And for the SQL pool, I'm paying by the time that it's on. So this is, I think, like one of the biggest features or services that we have here in Synapse, because I can say, hey, I just want to query that data, and I want to get it now, and I don't want to hold the whole SQL pool just for that. So that's really cool.
Yeah, that's really great.
And this is actually, I think, one of the biggest advantages. All right, so that was that. But what I want to show you is how I work with Spark. So notice that I'm picking up the file and I'm clicking on new notebook. And the new notebook already gives me like a snippet of code that I can start working with. If you look at the top, so this is my notebook. I can add cells, I can run everything, I can publish it, I can attach it. So I can decide which pool to attach it. I have only one Spark pool, so this is good for me.
So this works a lot like a Jupyter notebook, right?
Yeah, exactly. It works a lot like a Jupyter notebook. And I can pick up the coding language the programming language that I want to work with. So it can be PySpark, and this is specifically Python. It can be Spark, and then I would work with Scala API, .NET, C#. Or if I want, I can work directly with Spark SQL. All right, so I'm going to work with Python today. I don't need, this is called magic. So when I do that, basically double percentage, it kind of give me the different magic commands that I can do. So if you saw in the beginning, I had this one, the PySpark.
Right.
But you know what? I have multiple things that I can do with it. And it comes with a nice auto completion, so I can actually see everything I can do.
Very cool.
I don't need to memorize it, which is, I think that's cool.
Yeah.
All right, but I don't need that because the whole notebook, I defined the language as PySpark. And let's see what it gives us. It gives us spark.read. So this is how we are reading data and batch processing. Load, okay, it gives me the file path, so I don't need to go and look and search for it. It's already here, and it gives me the format. You know what, let me make it a little bit nicer looking code-wise, just because I don't like how it is. Give me a comment if header exists on comment line below. Okay, I don't need you. I do need the header. I prefer to look at it like that, just going to be easier for me to read. And you know what? I have a nicer way to provide the format. I'll just do CSV.
And this is just standard Python that you're writing here, right?
With Apache Spark library.
Oh,
so
okay.
Let's just do this one. You know what? We didn't start our pool yet. So I'm just going to call Spark now, and it's going to start a Spark session for me.
Okay.
Usually take about a few minutes, like 3-4 minutes, because it's an open source Spark. It's not optimized. Usually take a little bit time to start the cluster. You know, make sure all the libraries and all the requirements and all the configuration are in place. All the different machines got it. So this is how now we're starting the session. All right, let's look here. Header true. So once I give it header true, what Spark does, Spark going to create something called data frame. And a data frame is an abstraction on top of my data. So I can, after that, use the data frame to run multiple functionalities that Spark gives me out of the box. And here I'm telling it it's a CSV format. I have a built-in CSV functionality because it's already know how to work with it. And I'm specifying header true, which means infer the schema directly from the file that you're reading. Most of the time, what we see with CSVs, it's they basically translate everything into strings. So probably all our table or our schema is going to be out of string types. So like you said in the beginning, you know, sometimes we need to change the type. So that's exactly it. We're loading the data, we're changing the type, and then we can save it in a different format. They're actually going to hold the type better for us than a CSV.
I've never, yeah, it's been a long time since it happened, but when I remember so many times just playing with data, trying to get something out of one system and into another. And during the process, you know, going from CSV and then probably like into an Excel, into like viewing the CSV within Excel or something like that. And then seeing like what should be a date field or some other really long number field, like turn into, or some other, I think it usually is a date field, but you know how like you'll get these fields that'll suddenly say 2.333 E107, and it just like changes the entire thing. I have lost so many hours of time just with stupid things like that, because it'll happen and then you won't even spot it until, much later in the process, like somebody brings it up to you and shows you it's wrong. And it was like record, 12,000. Of course you didn't see it because you were like spot checking. Anyway, I'm going down this like bad memory lane of the data was brought in and not enough effort was given to make sure it was in the right format, and it just screws everything up totally.
Yeah, well, you're not alone. We all been through it, and probably, it's going to happen again.
Yeah, but at least we're coming up with things that can help with the process now, like the ingestion pipeline.
Exactly. I always think, the more we automate, the less place for bugs and things like that. So we can only focus on the logic itself and not the and not other things around it. But yeah, well, slowly it's coming. All right, so I see my cluster started and I have a Spark session, and let's run this thing. So it's going to read from the CSV, infer the schema with either true, and then we're going to call limit on it. So limit is a SQL functionality that tells it, hey, take just the first, X amount of records that I want to read. So here it's 10 records, and then it's going to display it nicely in the notebook. I can see the job execution is in progress. It shows me the different jobs that it's running, and it's soon going to finish. And here it is. Basically, I can see that display actually translate into take action. Take action is another Spark functionality. So that's good to know. It kind of, it shows me what happened there. Yeah, and this is the data that I have. So we are working with the Austin Animal Shelter data sets. I can see age upon outcome, animal ID. So each animal has their own ID. Animal type. Yeah, I picked a file that contains the cats, as you can see here in file name. Different breeds of animals, colors, date of birth. This is probably our biggest nemesis, right? Different time formats.
That's the one.
Yeah, and we have multiple fields of that. I mean, it's not only one. There's
exactly, and then you start seeing the ones in there like this, where it's got the it's not a UTC format, but where it has the T, the letter T in the middle of it to distinguish the time. Yeah.
I always say to people, let's just use UTC, and just don't do that. But okay, each one to his own.
One battle at a time.
One battle at a time. We have names. Some of our pets has names. Outcomes. So offsite, not really sure what that one, but maybe it was sent somewhere faster. So I guess someone adopted. Oh, I can see it here. Adoption, transfer to a partner, return to owner. Okay. And this is just 10 of the records that we have. So kind of we get a feel of what exists in our data. Spied female, nurtured male. Okay, count. Probably, yeah. So each row represent one. Female or male. So we have the gender. I don't understand the period of the period range. Maybe it's like how long they spend in the shelter. Can be.
Yeah, that's what it looks like.
Outcome age, if it's a kitten or a cat. This one always confused me. I mean, at what stage a kitten become a cat? Is that like
once they're old enough to drive? I don't know.
Probably. All right.
My cat is 8 years old, but she's still a kitten to me. She plays like
same. Same. I think the difference, yeah, I think my cat is 7.5 now. She's going to turn 8. Um, I think the difference between like 1 month and 7 years is they run less and they get tired more
That's true.
frequently.
She's getting bigger because she doesn't run as often. She gets plenty of treats, but
Gotcha. Okay. Yeah, and
but
she
she's still my
wants
kitten.
candies all.
Yeah, exactly. She gets whatever she wants.
Good for her. Okay, so we have all this data. That's cool. We know it. We saw it. We saved it in something called DataPath. I actually don't like the name DataPath, so I'm going to call it DF because that's a shortcut for data frame.
Okay.
And I'm going to say cat, just because it represents only cats. And then I want to see the other one. I'm going to let it run. It's going to finish super fast because we already run that. And one of the great things that Sparks gives us out of the box is the sometimes it will keep in memory the different results and the caching. So we get it kind of without calculating everything from scratch. All right, I want to do the other one. So we have another file that we want to load. And the other one, let's grab the name from here. So here I'm looking at my storage directly from the Azure portal. It's easier for me to kind of navigate it. I can also use Data Explorer. I have that installed on my device and I'm connected to Azure. So I have multiple ways to look at my data. And I'm grabbing the second one.
We've got another question in the chat about access into Spark, into the UI from within Synapse. Is there a way to get to the Spark UI from Synapse?
So clicking it here, it's going to give us the Synapse Spark UI. Sometimes it takes a little bit of time to load. It shows us the different jobs, tasks that we run, the different jobs, and then the different stages. For each of the jobs, what was completed, how long it took, what was the input, how many. So in Spark, basically the Spark breaks every jobs into multiple tasks. So since we work with relatively small data and we don't need to do we don't need to separate it, we can see it here. The skip stages, yeah, because you remember I told you had already saved into caching mechanism, so it skipped that one. It didn't do it all over again.
Cool.
I can look at the storage, the things that I'm working on, size and memory, how much of that was cached. So caching, again, exactly what I said. It caches the thing in memory. So even when I run it again, it knows it's this specific data was already cached. I can see my environment. So when I configure, Spark has a lot of ways we can configure it, and I can see all of that from here. So let's say we're going to touch it a little bit later, but we have in Spark something called a driver and an executor. And I can see the memory overhead, and a lot of different functionalities in here. And sometimes we want to update this thing. Sometimes we want to change the configuration and how it runs and what it uses. Environment type. I started as a production environment type, but we can do testing, staging, developer environment. And since we said Spark is a distributed systems, it runs on multiple machines, and we have something called a driver and something called the executor. So the driver is in charge of taking our code, analyzing it, and then splitting it into different tasks, and then it sends it to the executor to operate on those tasks. So here is where we can actually see the machines that we're working on. So we have the address, the driver. Only the driver has a name actually here called the driver. The rest of them are the executors, and we can see it from the numbers.
Right.
We can also look at the logs. When you
Mm-hmm.
have an issue, most of the times, you're going to the logs, you're going to your, if you have an observability system or, something like that that can collect the logs and can collect what happened, you can go there if you have like a dashboard.
Yep.
But if you just want to see what happened there, you can look at here. Actually, I think here we won't see much because we didn't do much. Yeah. Okay. So great question. This is how I can look directly at the Spark UI from my notebook.
That's handy.
So, yeah, especially when I have issues, and
Mm-hmm.
there are always issues. Okay, so I got the cat one. Now I'm doing the general animals. AAC, shelter outcomes. I'm just checking to see that I got the right file name. All right. Cool. It does this one. Let's just run and see what we have in here. So this is all Spark code that we're writing here. So
Okay.
nothing is special to Python or nothing is special to Synapse. It's all Spark code. Okay, and here I can actually see I have different animal type.
Mm-hmm.
So if before I had mostly cats, I have here dogs and others. So that's really interesting. Let's define it as a table.
I'm really curious about those other animal types with a breed of a bat mix and a squirrel mix.
Yeah, I saw it too. I was like,
what did it mix with?
Good question. I don't know.
What are they doing in Austin? I know Austin has the bats under the bridge, so they have like I wouldn't say a bat problem, but like it's a big part of it's an area full of bats.
What is it?
What are they? What are the bats? What are the bats breeding with? Yeah.
Interesting. That's interesting. I don't know about that.
Would you go to the animal shelter to get a bat?
I don't think you can adopt a bat. Maybe you can help them.
What's the outcome? Can we foster a bat?
I don't know. Let's see. Let's look specific at that line. It doesn't give us the animal types. Rabbits. Oh.
They don't have names.
Okay.
It's a rabies risk.
No. Yeah.
Interesting.
All right. Another cool thing that Sparks allows us is to write SQL queries.
Mm-hmm.
And in order to write SQL queries, I need to first define my data frame. I need to give it some temp view. So I really like the autocomplete here because I always forget to write create, but here I just write. I remember there is a temp view, so I'm writing temp view, and I have a list of things I can pick up from. So global.
Do you have room to scroll up just a little bit? Because we're getting kind of cut off at the bottom of your screen here.
Sure. Let me just do this. Can you see it?
It's better. Yeah. There you go. Just a little bit better.
Okay. So here I can actually define the different meta store that I have for Spark SQL. I can give it my specific data frame. Oh, my cat came to say hi. A name.
Perfect timing.
Animals. Yeah. You can probably see a tail or a face. All right. So.
Oh, hi, friend.
Hi, Juju.
I feel like I should go get Jolene.
Yeah, we should have a pet party.
She's sleeping right over here. I'll get her. Maybe at the end of the show, we can get them to say hello to each other.
That will be great. I wonder how they're going to react.
Just like a cat.
Yeah. Probably don't care.
Nope.
All right. So I created my animals and I want to look at my workspace, right? So I
Mhm.
created my animals temp view, and I can do so I can do spark.sql, and I can basically write a SQL query, whatever I want.
Okay.
So select, let's take what was interesting in here. I want to take animal type because I want to see what else are hitting in here. All right. Animal type from animals. Yeah, basically it. And I want to save it into types, animal type, data frame. Basically, let's hit it. We're basically just selecting one of the columns and saving it into a different data frame so we can do whatever we want on top of it.
Right.
One important thing to remember is Spark has something called lazy computation. And lazy computation means I can basically write a lot of code, but it's not going to operate on that code until telling it to operate on that code. So for example, here I did animal type equal, so assignment to something that comes from here, and it comes as kind of, we see, I don't know, it's a little bit small, but command executed. It doesn't mean that it loaded the data yet to where I want it to be, because it's lazy computation. Only when I do display.
So it's just in memory then?
It's not. It might be not even in memory. It might still be a query and still in like a query plan before running it.
Oh.
So it can optimize it if it needs to.
Super lazy. It hasn't even started yet.
Super lazy.
We'll call that a
I think here
procrastination.
Absolutely. I think here specifically, it's probably in memory because we already loaded and we saw in the Spark UI that it's already there. But yeah, all right. Display type, and I picked 10 different. All right, so I see mostly cat, dogs, other. It's not good enough. I want to know what the amount, how many types I have there in the data, right? So I can do animal type, and I can call distinct function. Again, another Spark functionality that's going to bring back the distinct values of that specific column. So distinct, and I'm going to call collect. Collect actually brings everything into memory. So I'm assuming this is going to be a very short list that's going to come back. Hopefully I am right. But collect function is we need to be super careful when using it, because it basically brings all the information from the different executors to the driver. And if I don't have enough memory, I'll get an out of memory exception, basically. All right, so are you curious to see what kind of, animal types we have?
Definitely. What kind of animals do we have in Austin, Texas?
Yeah, so we have livestock, birds, cats, others. We know it's probably a bat or something, and a dog. Okay. Now I want to know how much of everyone is there. So functionality that I need to do, I need to kind of group it. I need to group them by the different types, and then I need to count for every type how many of the same type are in that specific group.
Okay.
So let's do that. Group by, and I'm giving it the name. This is animal type. List and E. Here we go. Counts. All right. Oh, right. I forgot. Counted type. So what it did, it basically returned something we called a pointer to the data frame. It told me, hey, I created a data frame with animal type with two different columns. One is animal type string and a count, which is big int. But this is not what I want. I want to actually see what I have in there, not only the data type that I created.
Mm-hmm.
So we'll do the same trick with the display functionality and collect. All right.
Is it display?
Display,
Is there two Y's?
right.
Yeah.
Yeah. Absolutely correct. I have a typo here. Thank you. Pair programming.
Yes, exactly.
Yeah. Right. How many bats do you think we have?
I feel bad picking on the bats, especially knowing their outcome. Probably just one. That's got to be a weird thing. No, look at all those. No, that's what's in the other.
So we don't know what in the other. We're kind of guessing, I think. So livestock 9, birds, handful, cats, others, and yeah, dogs are on top. So 44,000. Interesting. Okay, cool. Now I want to save that data, right? So I looked at it, I played with it, I understand it a little bit. I see maybe there's not a lot of things I want to change in here, and that's cool. And now I want to save it. So I'm basically closing the loop of how my data pipeline. So I started with reading data from Spark, and then I progressed into looking at it, analyzing, thinking what I want to do with it, changing it maybe a little bit, picking only specific columns, understanding what exists, and now when I'm happy, I want to save it back. All right, so let's go back to at the top. See, let's take the data frame with the animals. And before saving it, we'll do a print schema.
While you're doing that, I just want to make a comment too for those who, maybe new to this tool or new to notebooks or, just curious about what's out there. So much of what you're doing, Adi, right now reminds me of about, this time or so last year when I was helping put together some of the machine learning content and some of the presentations, and we had just like this raw data we went through, and we used a Jupyter notebook, and we did some, I call it data engineering, but just, going through it iteratively like you are right now. And I don't know if this technically falls into the data scientist world, but there's certainly some overlap between, just this data, like core data work and database work, and a lot of the stuff that I've been learning as I've been pivoting, or not even pivoting, but just exploring out of curiosity, the more machine learning topics and the AI stuff. Like it's all very involved with a lot of the same type of things that you're going through right now. Just an observation, I guess. I know this isn't a machine learning topic necessarily, but man, does it feel like it could easily be.
Yeah, well, the way I see it, when we look at machine learning lifecycle, so usually at the very beginning, we have the stage of collecting the data, right? So we need to gather it somehow. And then we need to clean it and pre-process it.
Yep.
To make it ready for machine learning, for running our algorithms to get the machine learning model itself. So it's a lot similar. It's actually two of the main blocks of the machine learning life cycle,
right?
Or the machine learning pipeline. Sometimes we call it. Depends on how we look at it. And it's also part of our BI process. So if let's say I'm wearing the data engineer hat and I want to prepare the data for BI and processing, and I want to go over the data to check, if I have null values or if I have something weird in it or I need to change something. This is the same process. I'm not necessarily going to run some machine learning algorithm on it and produce a model. I just need it for, after that, so I can easily put it into a table and query the table with SQL.
Mm-hmm. Mm-hmm.
Um,
Yeah, exactly. That's what it kind of dawned on me that there's, so much overlap. And just like you're saying, like with the machine learning stuff, it's, bad data in, bad results out. Good data in, good data results out. So the more we start to rely on machine learning to help us with prediction models and all kinds of things, learning skills like this and tools like this to prepare the data before it gets to that prediction model phase is becoming what seems like more and more of a real big need out there. They need people who understand how to go through the data and clean it up and prepare it so that it can actually be used to help, help those prediction models, which help make business decisions. So there's that whole life cycle.
Yeah. And especially today when, we're trying to be as data-driven as possible, especially, with the unfortunate pandemic and everything kind of changed super fast. And people, not only people, business and companies are trying to make decision based on data. They want to understand, what's going on in the last week, what happened in the last few days, because they want to be able to make data-driven decisions. And sometimes, especially now, like data from a year ago, not necessarily relevant anymore because
Totally. That's right.
Everything.
Time's just speeding up. Yeah, things that we captured a while ago, it's good for historical reference, but it sure doesn't tell us about today. Yeah.
Yeah, so we need something that, we can work on the data from the last week, put it somewhere so we can query it. So the business analyst can come in and say, hey, I have everything ready for me and I just need SQL, some SQL engine to run it, or a SQL warehouse to start analyzing the data. And yeah, it's up to the data engineer to make sure it's nicely served, it's organized, it's clean, it's quality data, because like you mentioned, garbage in, garbage out. And we don't want to make garbage data-driven decisions.
No, not at all. Well, hey, just a quick time check. We've got about, I don't know, 10 to 15 minutes or so left before we got to start wrapping up. So what other things do we need to touch on before we say goodbye today?
All right, so I'm going to show you one functionality of how we can fill in null values, and one functionality of how we can drop null values pretty fast. And then we're going to save everything to Parquet. And I'm going to touch a little bit what Parquet is, and also how we can save things here in our database, so we can in our Spark database, so we can later on access it.
Great. I'll shut up. Quit asking questions, so you can get through all this stuff.
All right. Please ask questions. All is good.
Yeah, it's awful quiet in chat. If you got any questions, don't hesitate to ask.
All right, so one of the functionality I really like is the drop NA and the fill NA. And why is it so great? Because I don't have to write this code and iterate over the data. It's going to drop the null values that I have in specific fields, or fill in the null values that I have in specific fields with default value that I give it. So let's start with the fill NA. All right, so it wants a value and a subset. Let's give it, let's think about name. So I'm going with the column. Oops, what am I doing here? Here it is. I'm going with the column name. And let's say if I have an animal without any name, I'll just call it no name.
Okay.
Let's say if I got the syntax correct and the fill name is going to return a new data frame, like I mentioned. Okay, and then a frame, let's call it with default name and run it. All right, so now I should have no more rows with a null name. So let's do select. I want to select the name. I'm going to bring in the name. Oops, need to give it where. Cool. Right, so now I need to bring in the SQL functions. So I always forget how it was. Let's just trace if it's going to give me import Spark. All right, let me just search it for Spark SQL imports. Import functions. I'm also jumping between different languages. So I'm jumping usually between Python and Scala. So it's always like, get me, I'm like, oh, ooh, that's Python syntax. Oh no, that's Scala syntax. All right. Okay, yeah, that was my from PySpark. Exactly, I got a syntax wrong. SQL. And I want functions as func, and I'll just do func.call. From, sorry for my Python weirdness here. Okay, where name is for some reason I think I brought the wrong functions. Let me just bring the syntax. All right. And show or collect. So it's running. All right. Yeah, return nothing. It means I filled out all my null values. So cool. This is great.
Yeah, that's good.
This is what I want to show you. All right, so now I actually want to drop some rows that has now value.
Okay.
So I'm going to do the same thing. I'm going to take this one and I'm going to tell it drop NA and which field, let's say colors. So if they don't have, I'm just going to call it data frame. If they don't have a color, then the specific animal don't have a color. I don't want that. Okay.
Mm-hmm.
So before that, I did the should be any or all. Okay. Yeah, because I have a string there. So since I have a string there, it doesn't really the drop non-availability not gonna give me anything out of it, right? All right, so let's just skip that and go directly to saving our data. Now that we have filled it, we play with it a little bit. So I can do write, and I can write it to Parquet. And Parquet is a columnar file type that has different optimizations built in already. And I can save it directly into Parquet, and it's going to save my schema in a way that later on when I'm loading it with a, any Spark that I want, any Spark cluster or anything I want to work with it, it's going to load the schema exactly the way I saved it after I manipulate it. Also will be later on available for wherever I need. So that's really awesome. Now let's give it a path. So let me take, I want to give it this one. But I don't want to do the raw because I'm already saving it in a different folder. So let's say refined or curated. It's actually a better one. Curated, and it's going to be animals. All right, running it. And let's see. Right, execution, 2 executors, 8 cores. What happened in the Spark UI? Let's look at that. It's always important to know what's, what happened. All right, so Parquet. I can see it there, job grouped. Basically only one stage. Didn't do anything so special about that. It's already cached in memory. But I can actually see on any task, on any Spark job and task that I'm running, I can see how long it took it when the executor added to the mix. So I can tell how long things took just, to kind of warm up. For example, let's take our first one. Let's see, maybe they have a different, oh, here it is. So I can actually see in what time they added the machines and what time it was accessible. So look at all of that. That's really cool. It's really, yeah, it's really cool, the UI. It gives me a lot of visibility into the distributed system itself. Let's see what else. Yeah, I can see the caching. Oh, one thing I wanted to show you. Let's see if that's here. Oh, yeah, the event timeline we saw, adding executors, the different tasks along the way, job group for statement, succeeded, how long it took. If something failed, I will see it in red. If something is still running, let's say I have a stream job that's always running, it's always on, so we'll see it always on. Skip. Okay, cool. So I saved it to Parquet. Let's see if I can already see it. So we save it under Austin Animal Shelter, curated at animals. Okay. This looks at the raw data. Want to go back one. Curated. Whoops, didn't load yet. All right. Let's look at it directly from here. Again, this is the Azure portal to look at the storage. Yeah, I can see my directory is still here, so probably Synapse didn't catch up yet.
Mm-hmm.
And I can see the files. So I can see my Parquet files here, the size of them. I can see, this is we call special file, magic file, sometimes we call it, that actually tells me that my transaction and that the Spark job I did was succeeded.
Mm-hmm.
And that's really important because sometimes, since Spark is a distributed system, there might be, like race condition or anything like that. Like one executor succeeded, the rest failed. It also sometimes it writes into a temp folder to do all the calculation and then copy it to the destination. So it's really important to see here the success, because then we know it actually succeeded. Before that, without that, sorry, we can't know. It might be that the data is corrupted. So if I'll take you back to that time you said, hey, I worked with the data, but then we lost data because we had millions of transactions and stuff. This helps us understand what's going on in the system, make sure that, this is like the magic file that we always try to understand if, everything is okay.
Cool. Well, Adi, we got one question, and we are kind of getting low on time. We got about 2 minutes before we get before we get booted off. So first of all, thank you for showing all this to us. If we don't, and I'm just going to bring us back to a conversation here as we start to wrap up. This has been awesome as usual. You've blown my mind. And we had some questions in chat. In fact, one of them, I was starting to have the same question. I don't know if you can still see the chat in there, but really was just wanting to understand what's are there any other big differences between Synapse and Databricks? Because it seems like the Azure Spark piece is the main difference there. And then also, how does HD Insights fall into all of this in 1 minute or less?
So there's a huge difference between Databricks and Synapse. Well, one is Databricks is managed Apache Spark cluster, versus Synapse is based on open source and is not optimized. So if you work with things like Delta Lake, MLflow, a lot of different libraries, they integrated and they managed directly from Databricks. So if you're doing heavy Spark workloads and you need that optimization, go with Databricks. Regarding HD Insights, so HD Insights is a service that helps us work with different open source workloads. It basically gives us the environment to work with open source workloads. So it can be Spark, it can be Kafka, it can be Hive, it can be a lot of different open source that comes from the Hadoop ecosystem. It's a huge, huge ecosystem. So if we want something like that, and we want the more agility and flexibility of deciding how we want to plug different things, that's great. Synapse gives us the kind of one warehouse to do different tasks we want with our data. So it connects the different pipelines. If we want to copy, move our data, it connects, it has the SQL warehouse that is super fast. Also the SQL on demand that is super fast. So if it took me like 5 minutes to kind of start a Spark session, with Synapse, I can, if I only need to do like SQL query and I don't need to write code for it, I can do it with SQL on demand from a Synapse environment, or connect to my SQL on demand that Synapse provides me. So this is a little bit of the difference there, and it really depends on the workload that you're working with. They kind of decide how you want to combine them, or if one is better for you than the other. But the more advanced scenarios combine multiple, because sometimes you need different things for different people. If the data science are not big into SQL, but they know how to write Spark code, or if your BI people in the company are expert on SQL, then maybe you need a SQL on demand. Depends on your data needs.
Always depends. Yeah, it's always the answer. Okay, well, Adi, unfortunately, we are out of time, but it has been a pleasure to hang out with you again. I miss you. I'm so glad we got to do this today. And take care over there in Tel Aviv. And thank you to everybody that's joined us on the stream, both on Twitch as well as Microsoft Learn TV. And we'll see you again, hopefully very soon. So take care, and we'll talk to you later. Bye.
Bye, Jason.
See ya.
See ya.